Today's episode is sponsored by the new Refrigeration differential pressure monitor from Westermeyer Industries. When the filter element of your coalescing oil separator is contaminated, it can hurt your system's performance and efficiency. But how do you know when it's time to replace the filter? Wait too long to service the filter, and you could end up with nasty filter blowout. But replacing too often can be a waste of time and money. The answer is installing a differential pressure monitor. The new Refrigeration RDP-01 differential pressure monitor is available now with Westermeyer Industries. To find out more, email sales@westermeyerind.com. Once again, that's sales@westermeyerind.com. Look for the new pressure differential monitor, available now.
Hi guys, welcome to the Advanced Refrigeration podcast. I'm your host, Kevin Compass. I wanted to take a quick minute to talk about one of our sponsors that make this podcast possible, and that's Parker Sporlan and the Catch-All Filter Dryer. Do you know what can reduce system efficiencies and reliability within your refrigeration system? If you answered contamination, you are correct. Sporlan Catch-All dryers have been around since 1947 and have been perfected over the years to capture water, acid, solids, debris, including sludges and varnishes. For best practices, change the Catch-All filter dryer if any of the following occurs. Initial system install, when a system is open for service or repair, when excessive pressure drop of 5 psi across the filter dryer, when the See All sight glass indicates water is present, when doing a T1-1 acid test kit says there's acid present, during a compressor burnout cleanup, and following a successful burnout cleanup. To find out more information, by downloading Bulletin 40-10 from Sporlan.com with all the Catch-All filter dryer information. Thanks, guys. Enjoy the episode.
Good evening, everybody, and welcome to Advanced Refrigeration Podcast. You're here with your host, Brett Wetzel, Kevin Compass, and Charlie Cunliffe from Thermo. How are we doing today, man?
Doing well, sir. Thank you for inviting me.
Absolutely. Tonight we are going to be speaking about communication issues with Thermo, and maybe we'll be touching on some other things that he wants to bring up. Tell me a little bit about yourself, Charlie. How long you been in the business? How long you been with
Thermo? Sure. I've been in the business for 40 years. The last 31 years with Sporlan. And I was originally a mechanical engineer, selling valves and mechanical controls. But I guess it's about 14 years ago, we acquired Thermo, and I took the lateral transfer over to the Thermo division. Mm-hmm. And I've been working with them now and, applying Thermo Alliance and Thermo FMD to the field for the last 12 to 14 years. Predominantly, most of my work has been with CO2 installations. As soon as that became more prevalent in the United States, there was a great increase of Thermo application. Thermo's been around for over 27 years, but before they were acquired by Parker Sporlan, they were predominantly, I would say, a Canadian firm, but for the last 10, 14, 15 years, we've expanded across the greater United States.
Okay. And so I mean, what are you doing currently at Sporlan Parker?
Okay. Well, I focus completely on Thermo, and in my position, I'm an application and specification engineer. So I'm involved from the first time someone calls and said, "Hey, we heard about Thermo. Can you come down and give us a presentation?" So I'll call it a 30,000 foot view, and then generally, if they want to get a little bit deeper, I come back and do a more technical presentation. And and then usually I stay with the client from that initial 30,000 foot view all the way through the first 1, 2, 3, 4 stores that they use microthermo on, and then fully pass it over to our integration engineers. But the one good thing about my experience and the way Parker has our division set up, if I'm working with you guys, Brett and Kevin, I can help you if you have a question on a Parker Flowcon, an A8 or an A9, or a Sporlin EPR valve or microthermo. I can handle those questions for you because I'm experienced in both the mechanical and the computer control side of the systems.
Okay. And what did you say you did before working for Parker Sporlin?
Before Parker Sporlin, I was actually in the supply business.
Oh wow. Okay.
HVAC supply business, and then from that to Sporlin, and then like I said, 12, 14 years ago when we purchased Microthermo, took that transfer over to Microthermo.
Awesome. Well, man, I appreciate you coming on. You want to get started in with the PowerPoint?
Yeah, sure. That's great, man.
All right, let's bring it up.
Okay, we all good?
Yes, sir. Go right ahead.
Okay. All right. So I just wanted to do a few brief slides. I didn't want to make this death by PowerPoint, but I wanted to talk about Alliance, a little bit about the protocol and the network, only because Alliance is different probably than a lot of the networks that you're currently working on, being that we're a distributed network. So let me just go over some of the basics of LAN. Now, there are other people who do use the term LAN or echelon, and it's a proprietary. The echelon that we use is the real deal. It's the international echelon. We have to pay royalties for every chip that we use. The whole idea with that is it enables manufacturers, no matter where they are from all over the world, we have to guarantee that if you get a VFD, if you get a rooftop, whatever the device is that you want to control, and it's echelon enabled or it has an echelon chip, we have to be able to integrate that directly in through microthermo. So a Bacharach leak detector, you just get the echelon enabled version with the chip in it, and boom, you commission it and integrate it right through the front end of microthermo. So the whole idea is that it's an open technology available to all manufacturers, and it's a worldwide standard, so it's plug and play. And what we mean by that is if you want to integrate, let's say Danfoss happens to be a competitor of ours, but if you or your customer prefers Danfoss drives, we're really agnostic. We will integrate a Danfoss drive into our system. It's just it has to be echelon enabled with an echelon chip, and that way, as I said, we can program it or integrate it directly through our front end. No motherboards, no daughter boards, no licensing fees, etc. So when it's true echelon, you've got to be able to program it, integrate it right through your front end, and it's got to be seamless, plug and play, without some of the other situations that you may or may not have run into. So being that it's all over the world, everybody has to agree that what we put out is open and interoperable. And just, I'm going to go over these terms very briefly because when I open up an application, you'll see some of these parameters in the background. A snivet, which is a standard network variable type, that could be an NVO, network variable output, or NVI, network variable input. UNVIT is the opposite of SNVIT. That's standard. This is a user defined, or you might call it a custom. Then there are standard configuration parameters that everybody has to agree to, and then there are user-defined parameters, and then we have the same, I'll call it a thesaurus or a dictionary, no matter where it is, all over the world. Objects, functional profiles. A sensor is a sensor no matter where it comes from. Actuator, HVAC, lighting, refrigeration pump, you name it. So again, the whole idea is we're all talking the same language. We're all using the same protocol information, so that any device, wherever it's made, as if it has true open echelon, it's going to work through It's going to work through the Microthermal Alliance front end. So that's like 60 seconds on LAN. Of course, we could go into that much deeper. I really wanted to show the group this because these will turn up when I go into a live site. You'll see some of these descriptors, and just so that you have an idea of what you're looking at. And we've used, a lawn for 27, 30 years now. I know other people are 485, BACnet. We've been really happy with Echelon. It's very granular. It lets us get down to the nth detail. The conductors we use are very robust. And again, it's used on bullet trains, subway systems, and in mechanical control systems all over the world. So that's why, at least for now, as far as I can tell, we're sticking with Echelon for our protocol and our communication. I think we're probably considering perhaps a BACnet option in the future, but right now LAN has worked so well for us, we're going to stay with it. So the communication that we use is FTT10. And that's 78 kilobits, 78,000 bits per second. And the topology we prefer is either star or free. And each network channel can go up to 1,640 feet. And we don't want daisy chains. I know that's a term that other communication people use because it's rightfully applied for their technology. If you do go into a startup and you see that the communication or the electrician contractor has done a microthermo store and the network has been done in one gigantic daisy chain with a terminator on the end, run away because it's not going to work for you. That's an Echelon violation. So I have used bus, guys, in extremely large commercial applications. You can see the speed is in the mega, but for supermarket, we stick with the FTT10 and either star configuration or free. And anytime, guys, jump in if you've got a question on what I'm going over, but I just wanted to give you a background before we actually jump into a live store.
Charlie, can you go over the
Yeah.
difference between free and a star configuration? I understand what a star is. I'm not particularly
Okay,
familiar
cool. Absolutely. Great question. Okay, so I prefer, Kevin, I prefer a star because for me, that's easier to troubleshoot. And what you would do is you would land the balancing resistor right at the center of the star or the center of the octopus, and then all of the legs are emanating from there. Okay? With free topology, I can do a star on a star on a star. This pretty much is, it opens you free license to just make your connections any way you want to make them. The only caveat to that, Kev, is somebody darn well better make a hand sketch of how this was installed on the job, and then if you give that to us, we'll convert it to a CAD and we'll put it as a view in Microthermo, because this is totally, as it says, free. Means you can, as long as you observe, okay, 64 nodes per segment, no longer than 1,600 meters, you can freelance with this and you can make your connections however you want to make a connection. So right here, you see that's a star right there, Kev. That's a star right there. That's a star right there. So anytime we drop off of another one, we call it a star, okay? But the correct term for this is free topology, and really it's like a freelance, and you could make that network any way you want to make it. I mean, you could start with a main drop, a star, then you can have a star from a star, and then that tertiary star you made, you could make another star from that. So in other words, rather than this one where you start from a main starting point and you go in 1, 2, 3, 4, 5, 6, 7 different directions, okay, and then you've got channel A, channel B, channel C, channel D, channel E, okay. For me, that's easy to wrap my head around if I'm going to go to a store and troubleshoot. But with free topology, again, that's got to be committed to writing someplace, because, I mean, it's freelance. You can make the network whatever the heck you want it to, as long as each one of these subsegments, Kev, can't be any more than 64 simple nodes and no more than 500 meters or 1,640 feet.
That's how
Does that?
that's how a lot of the daisy chain stores I see are ran. They're ran free, right? Like they're just ran all over the place.
Yeah, but we see with this though, this I wouldn't call this a daisy chain because if this was a daisy chain, I would go here, then I come out of here and go over to, you know what I'm saying? It would just be one gigantic serpentine feed. This is, again, it's a simplified version, Brett. But again, this is a network segment, that's a network segment, this is a network segment, that's a network segment. So this is a simplified design. Let me go to up. Kev, do you have another question?
I had a real quick question.
Sure.
About the communication. You said that the only bus that you guys deal with is Echelon, correct?
We do, yes.
Okay,
And
so
again, that's just a bus network topology, okay? And we would use that for the speed. So I did a DNA lab, and I had hundreds and hundreds and hundreds and hundreds of nodes, and the temperature real time reporting back was critical. A bus network topology there.
okay, so but I mean, does that limit you to what you can connect to, or does most equipment now have the capability? Like, if you take a NIDEC drive, right, and you want to communicate with it, they do have different plugins that you can plug in, so you can either make it communicate via, IP or BACnet or Modbus. It all depends on what card you have. So is that how you get around? Just if you only, because I mean, most controllers have different open protocols, right? They do have BACnet, Modbus. But I mean, does that really limit you, or is there a lot of manufacturers that basically make a lot of those adapter cards to make the drive or whatever talk to Echelon?
Yeah, well, again, in the best world, we would like each device to be natively Echelon, but you'll see in a slide that I have coming up, we've done with Siemens, we've done some work with them where we can integrate their systems. So we're open to that if they have an ability through a translator, for lack of a better word, where we can bring their their communication into ours. We will definitely do that. So again, we'll take analog inputs. We do have the ability through adapters to get 485 onto our network. So again, we don't put a roadblock up against other forms of communication, but an alliance itself natively is Echelon for now.
Thank you.
Okay. So in the basic Echelon schematic, we have what's called the backbone. And then what we'll do is, again, now this is a star. This is a different version of the simplistic diagram. So a channel in larger stores will start with a router. So this schematic here has four routers or four channels. But we make a determination here. A lot of people always say, Charlie, where do I put my EOL, my end of the line terminator? And that is not what we want to do with an Echelon channel. We always want and I don't like it to call it a terminator because it puts people in mind that it's got to be end of line termination. I rather just say the resistor. You always try to look for the geographic middle of the channel, and that's where we want to land our resistor. So we have a resistor on the backbone. This is a star right here. I go to my first router. Go ahead, question. Okay, and then you see I start off of this node, I start off in this node. On this channel, I ran it down here, and then here's another star here. So again, this is not a daisy chain. In Echelon world, we call these networks or network segments. So this is a channel, and then you see a sub channel here, or a sub channel there, or a star here. And then another example is we come here, we drop down, and we drop over. So in this diagram, it's a kind of a mixture of free topology and star network, just to give you an idea of how open our network is. I mean, we allow you, as long as you stay within the echelon parameters, we allow you to design the hardwired network to use the least amount of cable possible, because the echelon cable, truthfully, is a little bit more money than standard communication cable. So we want the least amount of cable possible, and we but want balanced resistance on each network channel, and never put the resistor at the end of the line. Always find the middle of the network. So another way of thinking it is like this. So this is a boiled down version of a supermarket network. And it starts with what the guys in the trade call a data logger. That's actually a Windows industrial computer. And it's on what we call the backbone. So we put a 53 ohm resistor on the backbone. Here's the star right here. And then we have channel A, case controllers, and we can have multiple channels. Channel B, we can have a channel for rack A, rack B, rack C. Here's another channel for the HVAC system, and here's another channel for lighting. So you can have multiple. You can have 4, 10, 12, 16 channels, however many channels you want. Again, we don't want any more than 60, 64 simple nodes, or no more than 50 compound nodes. And again, your resistor should always be at the middle. So at the very end, or the first thing, Kev, on the startup, what you'll want to do is to get a multimeter out. And again, you want to never be any lower than 52, never higher than 58, no matter where you put the multimeter. If it's at the end, if it's at the middle, if it's out the router, check it in 3 or 4 places, but it should be within 52 and 58 ohms wherever you check every network segment. If you were on the HVAC system upstairs and you got to the end of RTU4 and it was 84 ohms, then I'm going to guarantee right now you're going to have a problem with that channel. They either used too much wire, they did one big ass daisy chain on the channel instead of doing a star where you cut down the amount of cable, or they did a bunch of courtesy loops or double backs. Again, everything should be as close to 53 as possible. Brett, Kev, any questions?
So far, boss.
Okay, man.
No, it's good so far.
Go ahead, Kev.
No, I said it's good so far.
Okay, cool. All right, so here's a biggie with the Echelon network, and if I harp on this, I apologize. I'd prefer you to use the Belden. I almost guarantee that if you use the Belden 16 gauge 8471 for both your main drop and your node-to-node communication, you will not have a problem with an Echelon network. It's 2-wire twisted pair, no shield whatsoever, 16 gauge, which is heavy duty for communication wire, and it's a minimum of 6 twists per foot. So it's the twist that actually creates like an EMF shield on the wire. I've had the bad experience of coming to jobs and, have guys do a big daisy chain and use the same wire cable that they would use for a 485 network. But I'd tell you right out, if you're going to do a store and you want it to work right with our technology or any Echelon technology, and by the way, this is an Echelon spec. This is not something that is dictated by Thermo. This is an Echelon spec. So 16 gauge 8471. There are other substitutes out there, but be very, very careful. You can go to Echelon and check to see what substitutes they consider equal, because sometimes you'll get a supply house and they'll go, oh yeah, it's Echelon wire, and then you get there and it's 2 twists per foot, the impedance is different, the resistance per 1,000 foot is different, and then you got nodes disappearing, they're on or off. It's just not worth it. So I always try to tell guys, please stick with the 16 gauge 8471. Now our 500 platform uses a four lug network connector. Our new 700 system uses a 2-lug, and the reason it uses a 2-lug is we try to tell people do not wire the network like this. We want both blacks bonded together and under the same lug, and we want both reds or both whites bonded together, twisted together, and under the same lug. That way, if this node gets smoked or somebody unplugs the network wire, you have not violated the network. If you wire it this way, if I have a problem with the node or I unplug it, I've now interrupted the network. So we try to preach that, but after a while we just said, well, we've got to do away with the 4-lug, and all of the new boards only have 2 lugs on them, so you can't make this mistake. So again, the network starts with the hub, the HMI, and the very first thing that comes out of the HMI is the USB adapter. Your black and white wire, that's the beginning of your FTT10 network, starts right there. The very next component that it's got to hit is the alarm node. Now, this is a real-time clock, and this is a scheduler, and this is a scheduler. So this board that you're looking at here is a compound node. This is a node. This is a node. Another one, and another one. So if I had 50 of these, that would be the maximum I would want on a network channel, because it is a compound node. We also try to pull the plug on this. We never want you to run the network in and run the network out of the board. So we pull that plug to make sure if you do get to a job and you see that somebody's got the network wire running out of here, start over. That's a no-no. You're going to have problems with the network because this is a main hub and everything communicates in and out of the alarm node. And if anything should happen to this, you're going to kill the network. So I gave you a picture here of an installation. Here's the HMI. That's not a master controller. Remember, all of these are smart nodes. They're microcomputers unto themselves. And then we program them and integrate them when we start up. So here's the Windows device, the HMI. Here's the USB adapter. Here's my black and white wire. Starts right from there. The very first thing I hit is the alarm node. Now you see there's no wire coming out of here, so that you can't make the mistake of starting your network from here. So we star over to here, and then we pick up these nodes, and then we go out to the building from there. Now, Brett, to answer your question that you had earlier, if you squint real hard, this is a Siemens connector here. So this was, I think, a Campbell's soup job, or it might have been an Aldi, and we had to integrate to the Siemens. And this, I'll call it a daughter board for lack of a better term, but this is the adapter that we used so that our technology and Siemens could link together.
And just so you guys are aware, what he was talking about before about those boards being smart, basically they don't need communication to the main or to each other in order to function. They will, most of the time the sensors are connected right to it for whatever function it's trying to achieve, and basically it can run independently. Now, if you have, I'm assuming if you have cases that are supposed to be going into hot gas defrost that are have to energize stuff on another board, I'm assuming that wouldn't work until you get network corrected, correct?
We would have to have a physical violation of the network, but that was a great point, Brett. So the store profile is kept here for safety purposes, but each one of these smart nodes, think of it as a microcomputer. When we program and integrate right from the get-go, in fact, we do the programming before we even show up at a job. All we do is service pin it when we get it there. That associates back to the HMI, and all of the parameters, whether it's superheat, whether it's a pressure, back pressure, whether it's controlling the gas cooler, all of those control parameters are flashed to that smart node or microcomputer. Now, should something happen to this HMI, everything will synchronized to the alarm node. That's why it has a real-time clock. If anything should happen to the the alarm node, then each one of these nodes has its own internal countdown clock, but it will be self-operating at that time, Brett, meaning that it will, if it's a case controller, it's going to continue to run the lights, the fans, the superheater, whatnot, but it will not be synchronized to the alarm node. So everything synchronizes to the HMI. That's how you report out to the real world. And should anything happen here, then everything synchronizes to the alarm node with the real-time clock. And then, God forbid, if anything happens, they have their own internal clocks that they will work off of. But once I program this case controller here, and it's in a meat case, it knows what it is. It knows what it's supposed to do for defrost. It knows what the superheat settings are. So it becomes self-operating, and the network only is there for nodes to communicate with each other, if necessary. An example of that, Brett, would be, let's say I'm doing HVAC in the store. So I've hung a temperature sensor and a relative humidity sensor so the HVAC system works better. Well, the beauty about a network is now that's an echelon device. It puts the temperature and the humidity on the network. So all I have to do is tell each one of these case controllers by checking a little box to listen to that parameter, which is always broadcast. It's an automatic broadcast on the network. Listen to the temperature and relative humidity, and guess what? Now the case controller becomes even smarter, because as the temperature rises or falls, or as the humidity rises or falls, the latent load and the sensible load profile is going to change to that case. And the case controllers get smarter because it's taken the feedback from the same node that's given the inside parameters to the rooftop units.
And there was something Charlie said, and I just want to make sure you guys understand that this as well. He was talking about, when he said the term, you have to hit the service pin. On Echelon devices, they have what's called a neuron ID. It's basically like a board address, and that basically is programmed into the controller via, by actually, typing in the node address. Or the other option is to hit the service pin, which basically, it's almost like activating your Bluetooth for a headset or something. So if you hit that, it basically starts, scanning, sending out a signal saying, hey, I'm looking for this board.
That is correct.
And basically that's how that works. So just in case you guys didn't understand what he said about the service pin, I just wanted to give a brief description.
Yep. Great point, Brett. Thanks for catching me on that.
It's nice. It's also nice because, it guarantees you get the right board.
Right.
Because you're physically going there and pushing the button.
Hey guys, I want to take a break and talk about Westermeyer, one of our other sponsors. Today's episode is sponsored by Westermeyer Industries, the leader in oil management and pressure vessels for the commercial refrigeration industry.
Yep.
Go ahead,
Brett.
The other thing that Microthermal is pretty good. So they have a function, like if you're, sometimes looking up, trying to find what particular board that you're looking for, it can be kind of difficult. They do have this function called Wink, where basically, you hit the board that you're looking at in the program, and it'll make the service lights go on and off, basically winking at you, say, hey, I'm right here, I'm over here.
Yep, absolutely right. So being that we got into it, so what we would do, the very first node that I always start when I'm getting a store ready is I always start the alarm node first. So I then go to the front end, the desktop, and I find the icon, the virtual icon that represents the alarm node. And then there's a button, a virtual button that says install. And there's an actual cartoon of a hand telling you to press the button. So what you do is you go over, squint real hard. You can see that that's a service button. You just press that for a quick quarter of a second. And what that does, Brett gave a great description. This looks back to the HMI. The HMI looks to this and says, oh, you're the alarm node. And boom, without you having to type anything in, everything that needs to be uploaded to this alarm node is done for you automatically. Now, yes, Brett is correct. If you choose, you could type in the alphanumeric, because every chip has its own individual, unique identifier. But for me, I'll fat finger it. I'll never trust myself, so I always use the service pin. So for the alarm node, being that it's a compound, I'd hit it here, and then I'd go to the icon for the real-time clock. I would hit this service button, and then I would hit the the scheduler for HVAC and the scheduler for lighting. Okay, and you can have multiple alarm nodes on a job. You can have more than one.
And when
Okay.
you are doing this, it's it's a lot easier to actually have two guys on site. If you're not going to do the Neuron ID, where basically you're going to write down everything, just be able to have the guy up there on the phone with them. Hey, I'm ready to look for this board. Just hit hit the service button, and then basically it just makes it a heck of a lot easier having another guy on site.
So
One thing that I do, I'm sorry to interrupt, but one thing that I do is I bring a 4G modem with me when I start up a store, and I connect it to the HMI, and then I take a 4G enabled or a 5G enabled phone or tablet, and I can start a store myself because I don't need to be at this panel. It's good to have two guys, but if you can't have two guys, if you make this data logger able to communicate to the outside world, then what I do is this screen here, this landing page here, I see the same exact thing on my phone or tablet, and then I'll get a ladder, I'll get on top of the frozen food aisle, I'll take the cover off of 20 different case controllers, and I'll just start and service pin, service pin, service pin, service pin, all the way down the aisle. I just have to make sure that I'm on the right icon when I do it, so that I don't misappropriate a case controller to the wrong location. Kev, did you want to ask a question?
that's exactly how I do it. Like I use the 4G router, and then I'll use an iPad, and then I'll walk around and ping everything. It goes pretty quick until you get to the coffins.
Yeah. Now, one thing that saves a lot of time, and I'll show you where to find it, we have something that's called delayed install. And what that does, it sets up the initial handshake between the safety profile on the data logger and the case controller or gas cooler controller or whatnot. But then it just stops right there, and then you can do 100 nodes in a day, because I'm going to tell you the truth. This alarm node here, that might take 2 minutes because it's not that complicated of a node. But a case controller, there's so many algorithms and whatnot, you could wait 5 or 6 minutes for that case controller to be fully integrated. So we have what's called a delayed install, and like I said, you can do 50, 100, 150 nodes, and the last thing you do before you go out of the supermarket and get back to the hotel and have a cold one is you go to the screen that allows you to do a delayed install, and then it picks up from where you left off, so you don't have to stand there and watch the screen for 5 minutes for each case controller. And overnight, while you're getting some rest, it's automatically integrating all of those boards for you and saving you time of having to stand there and get in front of just stand there, watch a screen while all the parameters are building for each and every node. Now, again, I'm new to your technology, so what I want to do now, Brett, is I want to log into a store for you and show you some of this in operation. So do I hit the stop sharing button for the moment?
Yep, hit stop share.
Okay.
Hit share again, and then this time, bring up whatever it should.
Okay.
I'm pretty sure it says web browser.
Okay. All right. So what I want to do is I want to get my team viewer going here. All right. And then I guess I'll have to minimize that and then share screen.
Mine right now at the top says Microsoft Edge tab, Windows or entire screen. So it'd probably be whatever browser you're using, right?
It's not going to be that. Hang on for a second. So
Yep.
let me get this up here. Okay. There we go. Share. Can you all see that now? Are we there?
There we go.
All right, cool. All right, so let me show you some of the cool things that you can do. Now, I listened to some of your podcasts, and I got to tell you, they're really good. And the speakers that you've had on talking about their type of networks, very, very good information. What we've tried to do with Microthermo, you don't need an oscilloscope, you don't need a signal generator. All you need is a multimeter. That's how technical you have to go. So let's say you're having a store with a communication problem. So the first thing you do is go right up to this tab here that says network, and then you're going to want to do architecture. Now what I'm going to do is open this up, and what this does is it gives you a complete roadmap of everything that the data logger is going to look for and exactly what chain it's in. So here you see the backbone, which I made reference to, and on the backbone you've got this circuit control, the alarm node, you got an MPC, you've got the HVAC scheduler, the lighting schedule, and the real-time clock that I told you about. Now in this store you have router 1, 2, 3, and you got a rack router. Now watch what I'm going to do. I'm going to drop down router 1, and then I'm going to drop down again, and now look, everything. So even if you don't give me a network diagram, at least you know everything that's on that router and the hierarchy or architecture that it's in. And any information that you want, if you just click on this, here's your identification. Brett, you brought this term up. Here's your neuron ID is there. The device name is XN54. The next one is XN57. The next one's 56. The next one, 55. So I'm going in order here. Okay, so it lets you know the hierarchy of how the data logger is going to look for that, and they're all, as I said, FT10. So this gives you a roadmap of the entire store. So here's router 2. I'm going to do the drop down, and here's everything. So this looks like it's an HVAC router, okay? And here is the rack router. I'm going to drop that down. Yep, circuit control, suction control, gas cooler, MPC, superheat exchanger. These are the valves for the flash tank. So everything that you want to know as far as the architecture or hierarchy of all of the channels are here. And again, all you have to do is highlight any one of those nodes in all of the echelon values that you may need to know are there. So, okay, that's the roadmap. So let's go into the real world. So let's go, here's router 1. Now, I want to know what the heck is on router 1 when the guy installed it. He didn't leave me a map, so watch what I'm going to do. I right-click on here, highlight connections, router 1 cases, boom. Everything that's on that channel turns purple. So now that you know router 1 is taken care of, this is the communication channel for everything that you need to know for router 1. So you just go back here, you do cancel highlight. Let's see what's on router 2. Highlight connections, router 2 cases. Boom. And you see it's all of these cases here. So if you're troubleshooting, if you got a bad actor and you have a node that keeps dropping on or off, at least to try to find it, what channel it's on, you could do this. So you just do the highlight or cancel highlight. Now, when you are looking at the visualized network connections node to node, as long as every dot you see here is green, that means every set point is perfect, everything, every temperature, every pressure is correct. If one of these nodes should ever go black, that means you've lost connection. Okay, visually, if you see a black node, it's lost its echelon communication. If one of these nodes were white, it means that it's not been configured completely. All right, so it's stoplight, green is good, yellow's caution, red is bad. That means you have an active problem. But the other the colors that you want to know about is black means you've dropped a node, or white means it's not fully configured. If you've dropped a node, you're going to get an alarm up here that's going to tell you that you've got a node failure or a communication failure. All right. So that's a simple way. So that's on the main landing page with case controllers. The same thing goes for, rack A in this store. I'm going to go to the suction controller up here. I'm going to right click and I want to know what are the nodes and points that are either controlled or associated by this microcomputer. I hit highlight connection, boom. Everything that turns purple is either a point that's connected to, or it is a device or board that's being controlled by this suction controller. Okay, so again, to cancel that highlight, you go here, you hit cancel highlight. Now, can you do it the reverse? Absolutely. I can go here. If I don't know where it's coming from, I can right click on this drive feedback. I can do highlight connection, and boom, that's it. So this and this are associated. They're working on a channel, and they're working or being controlled by this suction controller. All right. Go ahead, Brett.
Quick question.
Yes.
I know this is a communication question, but because we're looking at a transcritical rack, does Micro Thermo control their own, inlet valve and?
Yeah, great question. That's what that FGB was referring to. So yes, we have our own, and we've had it. We introduced it at ASHRAE, I guess about 3 or 4 years ago. Yes, we have a 2-valve controller. That controls the whole back valve for the gas cooler, and the valve that is the drain valve for the flash tank. So yes, the flash gas bypass valve is controlled. And we'll do a store with the Danfoss valves. A lot of OEMs like to stick with the Danfoss, so plenty of microthermal systems are out there with the Danfoss. We monitor it, but we don't control it. That's totally standalone. However, yes, Sporlan does now have its own controller for those 2 valves. Absolutely.
Okay.
All right, so now let me go to this here, gas cooler. I'm going to hit highlight connection. Now you see what happens. Intuitively, I know this, but only one dot turned purple, this little dot here. So what I'm going to do is I'm going to zoom in on that dot. You see it right here? I'm going to click again. That's a custom node. Now, Brett, you made mention of this. You might have 25 or 30 of these ganged up all together. Now I know virtually where it is on the landing screen. How can I find it physically? And what Brett mentioned, you go to this wink button. Okay, you click it once, and what that's going to do, it's going to be the opposite. Our normal blink is 1 second on, 6 seconds off, 1 second on, 6 seconds off. When I hit wink, that board's going to be 6 seconds on, 1 second off, 6 seconds on, 1 second off. So you can look at 3 or 4 boards next to each other, and now I've identified the board that I'm looking for because I've used the wink function. Okay. Now, my network variables, I can see them. Those are the NVIs and NVOs that I was talking about. Now, this is deep in the weeds. I won't dwell here too long. But, my rocket scientists, they're the ones that get into all of this. Most of what we deal with in the trade, we're dealing with everything that's GUI or icon based. We don't have to get into the weeds and do all of the zeros and ones. It's there, but just so that you know where it is. So that's information on the controller itself. We got a little bit of a lag here. Hang on.
What's GUI? I've heard that term before.
Yeah, graphic user interface. Thanks. Right. If I use a term, we have a hang up. Oh, here we go. All right, so now, again, I can't do this because it's already installed, but if this node was, never used, virgin out of the box, and I've applied power to it, again, like Kevin mentioned, we put a wireless adapter in there, or we put a 4G cell, and then we'll open up Microthermo, we'll get to this node, and we'll hit this install button. And then you'll see a bunch of numbers and letters flashing in the bottom of the screen. That is how you initially bring this online, and all of the parameters are flashed to this just simply by pushing that service pin button. And here's your Neuron ID, okay? If I ever have to recommission, I can do it from here, or I can do it from here, send configuration, and I'll show you a report later that tells you why you might want to do this. Who knows? Somebody cut power in the middle of when you're pushing the service button, so you got a broken install. The first thing we would do is do a reset. That's like a hard boot. It momentarily interrupts power from this, which is in fact a microcomputer, and then we can recommission it or restart the node by either loading node software or sending the configuration again. Now, if this has been going on and off, you can test right through the node just by hitting this test button. Right now, this node has passed all applicable tests. If you cannot communicate or there's transmission errors, that will show up by simply just hitting this test button. Okay? So your network variables, your LAN mark information, again, this is deep in the weeds. I won't dwell there. But if you really need to get to the nth detail with the nodes and troubleshooting, you can do it right through the virtual icon for the node. Brett, did you have a question?
Yeah, is there anywhere in so in the network setup for CPC, you can see how many COM errors it had. They in Novar they call it coefficient errors. Is there a screen that you can show us where basically it shows us how many errors each port had or whatever?
Yep. So let me go to network, and I'm going to go to node statistic reports. And let's just see what's happened. That's a year. Let's take a look. Let's go back to July. We'll go to July 7th to October 7th. I'm going to hit OK. And then these are most recent errors. None. This is clean. So let me go back further in time. Let me go back to May. Okay. Most recent errors. No errors. Okay. Let me go back to April. April 7th. Okay. MRE analysis. None. So this store is running so tight. Let me go back to March 7th. Okay, MRE analysis. Okay, there we go. Let me open. Yeah. Did you guys know that this report was there?
I didn't.
Okay, cool. Yeah, so listen, look what this does. So here, you were asking about the throttle and the flash gas bypass valve. What subsystem it was on? It's on rack A. Most recent errors, and it's an invalid domain. This error could occur if the network configuration is invalid, if the network management tool is malfunctioning, or if the neuron chip firmware image is corrupted. Action: try reloading the node software. So what we try to do for you is we give you the tips of what to do in case you have errors. And again, you're new to microthermal. We try to give you the description of the error and some action that you can take. And then you can see the count here was only one error. So that's not gruesome, but it's especially on something as critical as the throttle and the flash gas bypass valve. Yeah, this is a node that you want to make sure is doesn't have a problem. So what I would imagine is let's close this out. So that was March 7th. So let's see. Let's go to April 5th. Okay, let's do the analysis.